Hi everyone. I hope everyone's doing great. Now, let's get this started. Firstly, I want you to assume it's like 6 a.m. I want you to put somewhere just for a minute or so. So, it's 6 a.m. You're a drone operator and you're at an energy company. Your job is to actually fly over 30 miles of natural gas pipeline and also watch every frame, looking for rust on joints, heat signatures that shouldn't be there, trees that are going, vegetation, as a lot of things. You do know that it has a very strenuous job. Like you do think that it is a very daily, a very laborious job. Now, in that same note, right, let's say for example, at 30 miles per analyst per day, you need around 10,000 people working around it across an every day. So in an entire year, that's one of the critical problem that we are actually solving. So now let's come to our team. So we are a very quick introduction, right? So we are from Southeast Missouri State University. Again, we are Rights to Secure and Sort Now, two companies, one team. I am Hemant. I am an AIML researcher and a full stack engineer. I worked with around Ford, Deloitte, and I have multiple companies that I've worked with, around 7 years experience. Now, talking about my team member, Praveen. So Praveen is also has a similar background, but he's more into cybersecurity research, quantum security architect, and also he has won CCDC, which is like the Missouri State Championship in 2025. To be to be more precise about him, there's also QPC frameworks that he has worked on. And our third teammate is Maunish. So Maunish is again an AML engineer. He has worked with Accenture. He has worked as an MLOps engineer. He built Pen system. Again, this is corely built on Rust. Now, combining all these efforts, we have made something very impeccable within like 24 hours. That's what we have did. Now, let me show you what we have done and what are some of these metrics that we had done. Uh, Let me go directly to our um, application. This is where our demo gets started. Now, in this, there are four chambers. Like one is the live analysis. There's another called SSE stream, and there is a metrics that we can talk about. Now, just speaking about these metrics, right? There are these live analysis that we had made. In here, what we had to do is we just have to upload an image, essentially a video, which is having some of these uh, images of. Okay, so what we have done currently is we have uploaded our InfraWatch video. This contains some of the drone footage shots like corrosion, there is vegetation, there are also human detections, there's wildlife that can come in. So all these aspects we have consolidated into one particular video and we have uploaded it at this point. Now our system is actually running it in the background. You can just escape, hit the escape, and you should see some of the logs that will be generated. Let's say for example, um, let me do this again. Oh, I think it did the work. So if I go to escape, right, so you see this is more centric towards St. Louis. We used the data, we used the ingestion that we had was there was multiple videos, there were also geospatial locations, there was also a track of what are the sensor metrics that we were able to capture from the drone shots. Now if I go in a very detailed way, you see there are some red spots. These actually talk about, hey, this is a critical thing. And there's a warm spot which talks about, hey, this is something on a robust high scale that needs to look in. So if I click on this critical one, you will see essentially what sort of a corrosion happened. Hey, this is where you have seen some corrosion on the pipeline and you need to act upon it very very vehemently at this point of time. And also, if you look in here, there are the metrics of corrosion. There are also some things like people detected. At this point you might not see people, so if you just go and scroll about it, or there are some evidences where people are also available. So here is the, if you click on this one directly, you will see that yes, there is a heavy vehicle that went through. And if you click on this one, what's this red option that we are seeing? So here is the corrosion that is, it's been detected. And a very similar way, there's also people in this entire pipeline. You will also see there are people who are being detected. In this way, we get a composite risk score. So 85 is something which we have dealt with. Again, is there a methane exemption? Is there a temperature? What's the pressure? All these things we will be able to forecast. Now, closing this one, and this is very similar to any different videos. So you can go to any other clip as well. You will find how the heat metrics has been displayed. Yes, you can also see that we are also detecting wildlife as deers as they are passing by. We use this metric as well. This is one of the footage from the video. But yes, this is one. Again, this is on a live analysis. However, let's say for example there is a SSE stream, because a drone analyst will be able to inspect on a real time what's happening. So I am just clicking here something called start inspection. When we do this, the drone actually moves from one place to another place. Maybe the entire pipeline or the grid is a closed loop. Obviously, it should be a closed loop, and the path should be designated. And this drone goes in the entire path that has been designated for it. So if you look in, the drone is actually moving, and there are some places that it has detected some issues. For example, here on there's a red spot. What does this red spot mean? So when I click on it, or any inspector, drone inspector clicks on it, he will see that, hey, there is a critical thing that you need to look about. And once this get loaded, there is a corrosion. This is the detection that it has done. In similar way, you will find all these videos and all these evidences essentially to explain or make sure that this entire thing is being facilitated in a proper way. Now, coming back, again, this is on the SSE streamline. Let's say for example, everybody loves to know what's the post analysis of it. What did we actually get in? What is the report that we got in? So you can export the entire geo JSON data. So you click on it, you get this geo JSON, and you will be able to send it to your crew, to your co-workers, or even to the post-mortem reports that happen. Because essentially pre-analysis is also done. What happens is your data, what has happened, or is also essential. Now if you click on this analytics as well, so here's the pipeline that is getting loaded, and you will see what are the segments that are being scanned. There are 12 segments, there are 7 anomalies. How many are there critical, how many are what's the risk score? Everything we will be able to see in the entire video. You also see people are 5. So this critical things we will be able to deliver. So here are the anomalies, here are the heat maps, everything that is being used, or that is something that we have used. Now, coming back to our architecture, let's go with the architecture. In our architecture, right, so what we essentially have is, let me go to the architecture. Okay, now let me go back to our architecture. Now, if you see, this is a very 6-layered structure that we have done. In this one, there are the streams like ingestion layer, chunking, AI models, and everything. Now here, if I go into the ingestion layer, you will see the formats or the videos that we have given: the drone footage, the RGB videos, the thermal videos, the sensor telemetry, and also GPS telemetry. We had to formulate all these in a more synchronized way, and that's where we were able to get these data for one particular video. Now, chunking is something very crucial for us. We used Kafka system and the same architecture, streaming the entire video into chunks and getting it formulated or streamlined using SQS. Again, once the chunking is completed, we are monitoring those logs. We have passed those to Marengo and Pegasus, essentially to get the video embeddings and also to understand what the scene is, what this particular video is depicting. So we are getting all this data in the form of JSON, and we are sending it to our SageMaker, where our Fusion engine is working on it to make sure we have a composite risk analysis score. This is where the things get interesting. We get a regulatory threshold, we get things, we get high score metrics, we also get some of these low score, and also 0 to high tolerance of mission critical things. The entire architecture, again, we have deployed it into two ways. One is obviously Dockerizing the entire backend system, and we have deployed it as in REST API for the chunks, and also for SSE streaming, we use real-time events. So, and we also get the evidence clips for all these segment of videos. These videos or the evidences is mostly 30 seconds, but this can be prolonged depending on the impact. Now, talking about mission control, right? All these alerts that we have, the critical essentially, they will be sent towards the crew members or even to the drone supervisor, stating that, hey, there has been this corrosion that is detected, there is this thermal resistance that happened, and we were able to look in. So they send the email alerts using AWS SNS and also SES. So this is just more like a smart way how we can make sure the mission critical is being tallied upon. Now, this is about our architecture. And when I go to our accomplishments, right? So the detection score we had was 100%, because again, these are some things that Pegasus and Marengo was trying to give us, and it was able to detect us thanks for 12 labs. Now, second is domain understanding. We covered all the pipelines, we covered all the power lines and also substations. Again, talking about vegetation and also people and wildlife, we have added all these environment variables as well. That's one. In terms of technical implementation, we had the 12 labs models, multi-fusion, and also SSE streaming. These are some things that we had added upon. Again, if you talk about the SOC dashboard, we have kept our evidence clips, also the geo JSON exports and the confidence scores again. Another part of the entire thing is we implemented something called agentic workflow, just to combine all these three data sources and make sure that there is an auto mapping that happens, and also to alert the crew members. That's about the hackathon. Again, just some benchmarks. Yes, there is 100% precision on the test set anomaly identification, and also there's it's much more faster than any human intervention. Again, the estimated cost of it, obviously, this can vary upon, but this is something that we want to talk about, 1 million to 100 million. Again, in our mission critical thing, there are 7 anomalies that are detected, and we are open for questions. Thanks, team.